Hari Om. Hello everyone, I am Shrees. Welcome back to my channel. In this video, we are going through some important questions of complex number. So first question is, evaluate the following I raised to 457. See here, to find I raised to 457, first of all, let us divide 457 by 4. 457 divided by 4. 4 ones are 4. 0, 5, 4 ones are 4, 1, 7, 4 fours are 16. Remainder is 1. So it can be written as I raised to 457, that is equal to I raised to 4 into 114 plus remainder is 1. Okay. So that is equal to I raised to 4 into 114 into I raised to 1. That is power rule. Okay. I raised to a plus b. That is equal to I raised to a into I raised to b. Okay, now here we know that I raised to 4, the value is 1. Why? Because I is equal to square root of minus 1. Value of I is square root of minus 1. So that why I square is equal to minus 1 and I cube is equal to minus 1 into I, that is minus I. So I raised to 4 is nothing but minus I into I, that is minus of minus 1, that is 1. So I raised to 4 is 1. That is 1 raised to 114 into I, that is equal to 1 raised to any real number, that is 1 into I, so I itself. So the value of I raised to 457 is I. Next, second one. See here also I raised to 528. Divide this 528 by 4. I raised to 528, that is equal to I raised to 4 into 4 ones are 4, remaining 1, 12, 4 threes are 12, next 4 twos are 8, remainder is 0, right? So that is equal to, here I raised to 4 is 1, so 1 raised to 132, that is equal to 1. Next, third one, I raised to 37 plus 1 divided by I raised to 67. Here also divide 37 by 4. So it can be written as I raised to 4 into 9 plus 1. Right? 4 into 9, 36. 36 plus 1, 37. Plus 1 divided by I raised to 67. That is I raised to 4 into divide by 4. So 4 ones are 4. Remaining 2. That is 4 6 are 24. Remainder is 3. Right? That is equal to, here I raised to 4 into 9 into I plus 1 divided by I raised to 4 into 16 into I cube. That is equal to, it is nothing but 1 because I raised to 4 is 1. So 1 into I, that is I itself. So I plus 1 divided by, it is nothing but 1 into I cube. The value of I cube is minus I. So minus I. Take LCM, minus I square plus 1 divided by minus I. See, minus I square is minus 1, minus I square is minus of minus 1 plus 1, 1 plus 1, 2, 2 divided by minus I. Fourth one, let us find it one by one. I raised to 77. Here also divide 77 by 4. So it can be written as I raised to, here divide 4. So 4 into 4 ones are remainder 3, 37. So 4 nines are 36 plus remainder is 1. Right? That is equal to I raised to 4 into 19 into I raised to 1. That is equal to, it is nothing but 1 because I raised to 4 is 1. So 1 into I itself. Next one, I raised to 70. Here also divide by 4. So 4 into 4 ones are remainder 3, 30. So 4 sevens are 28. Remainder is 2. Okay. That is equal to I raised to 4 into 17 into I square. Here I raised to 4 into 17, that is 1. So 1 into I square. I square is nothing but minus 1. So 1 into minus 1, minus 1. Next, I raised to 87. So I raised to here also divide 87 by 4. So 4 into 4 2s are, okay, 4 1s are, remainder 3. Okay. That is equal to I raised to 4 into 21 into I raised to 3, that is equal to, it is 1. So 1 into I cube value is, the value of I cube minus I. So that is minus I. So next is I raised to 414, that is equal to, divide 414 by 4. I raised to 4 into 4 1s are, okay, 0. Next 4 3s are 12, remainder 2, that is equal to I raised to 4 into 103 into I square, that is equal to I raised to 4 is 1, so 1 raised to 103 is 1 into I square value is minus 1, so 1 into minus 1, minus 1. Okay. Next, okay, now let us find this value. I raised to 77 plus I raised to 70 plus I raised to 87 plus I raised to 414 whole cube, that is equal to I plus minus 1 plus minus I plus minus 1 whole cube. Here plus I minus I cancelled. So minus 1 minus 1 minus 2. Minus 2 cube is nothing but minus 8. So the value of this fourth one is minus 8. Next question is, show that 1 plus I raised to 10 plus I raised to 20 plus I raised to 30 is a real number. See here, 1 plus I raised to 10 plus I raised to 20 plus I raised to 30, that is equal to 1 plus, see, I raised to 10 can be written as I raised to 4 into 2 plus 2, right? 4 into 2, 8, 8 plus 2, 10. Okay. Plus, here, I raised to 20 can be written as 4 into 5, right? Remainder is 0. Plus, I raised to 30 can be written as I raised to 4 into 7 plus 2. 4 into 7, 28, 28 plus 2, 30. That is equal to, here 1 plus I raised to 4 into 2, okay, into I square plus I raised to, it is nothing but 1, okay, here itself we will write. So I raised to 4 into 5, that is 1, plus I raised to 4 into 7 into I square, that is equal to 1 plus I raised to 4 into 2 is nothing but 1 into I square, that is 1 into I square is minus 1, 1 into minus 1, minus 1 plus 1 plus I raised to 4 into 7 is 1. So 1 into I square is nothing but minus 1 into 1, minus 1. So here 1 minus 1 cancelled, 1 minus 1 cancelled. So 0, 0 is a real number. See the next question. Express the following complex numbers in the standard form a plus ib. Given complex numbers, these are complex numbers. See, we have to write it in the form of a plus ib. So first one, 1 plus I into 1 plus 2i. Expand this. So 1 into 1 plus 1 into 2i, 2i plus I into 1, I plus I into 2i, 2i square. Okay. 1 plus 2i plus I, 3i plus here 2i square, right? Okay. So I square value is minus 1. Minus 1 into 2 is minus 2. That is equal to 1 minus 2 is minus 1 plus 3i. See, now it is in the form of a plus ib. Standard form a plus ib. A is equal to minus 1. That is real part is minus 1 and imaginary part is 3. Next, second one. 2 plus 3i divided by 4 plus 5i. See, if the complex number in the form of p by q, you just take the conjugate of denominator. See, here denominator is 4 plus 5i. So, its conjugate is, that is, how to write the conjugate? By changing the sign of imaginary part, right? That is 2 plus 3i divided by 4 plus 5i into conjugate of denominator, that is 4 minus 5i divided by 4 minus 5i. Okay, multiply 4 minus 5i divided by 4 minus 5i. That is equal to, multiply this one. Here, see, so that the denominator will be a real part. Okay, we will get a real number in denominator. So, 2 plus 3i into 4 minus 5i divided by, see, now it is in the form of a plus b into a minus b, that is a square minus b square, that is 16 minus 5 into 5, 25, okay, 5 square, I square. So, minus 25 into I square value is minus 1. So, minus minus will become plus 25. That is equal to, now expand this, 2 into 4, 8, 2 into minus 5i minus 10i plus 12i minus 15i square, that is divided by here 41. 16 plus 25 is 41. That is equal to 8 minus plus minus 10i plus 12i, that is plus 2i. Here minus 15i square is minus 1 into minus 15 plus 15, okay, divided by 41, that is equal to here 8 plus 15, 23 plus 2i divided by 41. Now it can be written as in the form of a plus ib, real part, that is 23 divided by 41 plus 2 divided by 41 into I. See, now it is in the form of a plus ib, standard complex number a plus ib. A is 23 by 41, b is 2 by 41, that is real part is 23 by 41 and imaginary part is 2 by 41. Next one, third one. 5 plus root 2i divided by 1 minus root 2i. That is here also, see, it is in the form of p by q, and here also we have to multiply and divide by conjugate of denominator. Okay, that is 5 plus root 2i divided by 1 minus root 2i into, that is conjugate of denominator, we are changing the sign of imaginary part, 1 plus root 2i divided by 1 plus root 2i, that is equal to 5 plus root 2i into 1 plus root 2i divided by, here now it is in the form of a minus b into a plus b, that is equal to a square minus b square. So 1 into 1, 1 minus root 2 into root 2, 2i square, right? That is equal to, now expand numerator, 5 into 1, 5 plus 5 into root 2, that is 5 root 2i plus root 2 into 1 root 2i plus root 2 into root 2, root 2i into root 2i, root 2 into root 2, 2i into I square, so 2i square divided by, here 1, I square value is minus 1 into minus 2 plus 2, okay, that is equal to, here 5 plus 5 root 2i plus root 2i, that is 6 root 2i, okay, 5 plus 1. See, if you take root 2i outside, you will get root 2i into 5 plus 1, that is 6 root 2i, okay, 6 root 2i plus, okay, here I square value is minus 1. Minus 1 into 2, it will become minus 2, right? Divided by 3. Okay, that is equal to 5 minus 2 is 3. 3 plus 6 root 2 I divided by 3. Here 3 is common, right? Both terms 3 is common. So we can take 3 outside. 3 into 1 plus 2 root 2I divided by 3. 3 cancelled. Okay, so 1 plus 2 root 2I. So here it is in the form of A plus IB. A is equal to value of A is 1. Value of B is 2 root 2. Next question. 1 minus I whole cube divided by 1 minus I cube. See, first of all, let us expand numerator, that is in the form of A minus B whole cube. A minus B whole cube, that is equal to A cube minus B cube plus 3A square B minus 3A square B plus 3AB square. Let us apply this identity here. So 1 minus, that is A cube, 1 cube, A is 1, B is I. Okay, B cube, that is I cube minus 3 into A square 1 into B I plus 3 into A is 1 into B square I square divided by 1 minus I cube. What is the value of I cube? See, I cube is nothing but I square into I, that is minus 1 into I minus I. So I cube is minus I, that is equal to 1 minus I cube, that is I cube is minus I, minus minus become plus I. Okay, minus 3 into I plus I square is minus 1, so minus 1 into 3 minus 3 divided by 1 plus I. Here minus 3 plus 1 minus 2 minus 1, sorry, plus 1 minus 3, that is minus 2, so minus 2I divided by 1 plus I. Now see, here we have to make it in the form of A plus IB, standard form A plus IB. So here just multiply the denominator, multiply the conjugate of denominator, multiply and divide by conjugate of denominator, that is equal to minus 2 minus 2I divided by 1 plus I into 1 minus I divided by 1 minus I. So that we will get the real number in denominator. That is equal to, here expand, minus 2 into 1 minus 2, minus 2 into minus I plus 2I, minus 2I into 1 minus 2I, minus 2I into minus I plus 2I square divided by, here it is in the form A plus B into A minus B, that is nothing but A square minus B square, that is 1 minus B square, that is I square, that is equal to, here see, plus 2I minus 2I cancelled, here minus 2 plus, here I square is minus 1, so minus 1 into, that is minus 2 divided by 1 minus I square is minus 1, that is equal to minus 2 minus 4 divided by 2, that is minus 2. So here we can write minus 2 as minus 2 plus 0I. So here A is equal to minus 2 and B is equal to 0. Next question is, find the conjugates of the following complex numbers. First one, 4 minus 5i. How to write the conjugate of a complex number? Just changing the sign of imaginary part. See, first one, 4 minus 5i. Okay, if z is equal to 4 minus 5i, then z conjugate, that is equal to 4 plus 5i. Okay, just changing the sign of imaginary part. Next, second one, 1 divided by 1 plus I. See, here given complex number is not in the form of standard form. Okay, so here first of all let us make it into standard form, that is A plus IB. then we can write the conjugate of complex number. So first of all, let us make it to in the form of a plus ib. A plus ib. Okay. For that, see, first of all, here we have to multiply and divide by conjugate of denominator. Okay. 1 by 1 plus I into 1 minus I divided by 1 minus I. So that we will get a real part, that is a real number in numerator. Okay, sorry, denominator. So that is equal to 1 minus I divided by 1 plus I into 1 minus I, that is a plus b into a minus b, that is a square minus b square. So 1 minus I square. That is equal to 1 minus I divided by 1 minus I square is minus 1. So 1 minus minus 1, 1 plus 1, that is equal to 1 minus I divided by 2, that is 1 by 2 minus I by 2. Okay. That is 1 by 2 minus 1 by 2i. A plus ib form. Right. So now how to find, if it is z, then z conjugate, that is equal to, just change the sign of imaginary part. So 1 by 2 plus 1 by 2i. Z conjugate is 1 by 2 plus 1 by 2i. Now let us find the conjugate of third one. Given complex number z is equal to 1 plus I into 2 plus I divided by 3 plus I. See, here also given complex number is not in the form of standard form a plus ib. So first of all, let us make it in the form of a plus ib. So how? By multiplying and dividing by conjugate of denominator. Okay. That is 1 plus I. Let us expand this one. 1 into 2, 2. 1 into I plus 2I plus I square divided by 3 plus I into conjugate of denominator, that is 3 minus I divided by 3 minus I. Okay. That is equal to, so here 2 plus 3I, I plus 2I, 3I, I square value is minus 1 into 3 minus I divided by, here a plus b into a minus b, that is a square minus b square, that is nothing but 9 minus I square, right? That is equal to, here also expand it, 2 into 3, 6, 2 into minus I, minus 2I, plus 3I into 3, plus 9I, 3I into minus I, minus 3I square, minus 1 into 3, minus 3, minus 1 into minus I, plus I, divided by, I square value is minus 1, so 9 minus minus 1, that is 9 plus 1, that is 10. That is equal to, here 6 minus 3, 3, minus 2I plus 9I, 7I, 7I plus I, 8I, okay, 8I, here minus 3I square, I square is minus 1, so minus 3 into minus 1, okay, I square value is minus 1, that is plus 3. So it is plus 3 divided by 10. That is 6 plus 8I divided by 10. See here 2 is common, right? Numerator and denominator 2 is common. So let us take it out and cancel, okay? So 2 into 3 plus 4I divided by 2 into 5. To cancel. So 3 plus 4I divided by 5. So here that is 3 by 5 plus 4 by 5I. Now it is in the form of a plus ib, right? So what is the conjugate? See, conjugate, z conjugate is nothing but 3 by 5 minus 4 by 5I, or 3 minus 4I divided by 5 is the conjugate of given complex number. Let us go through next question. Find the multiplication inverse of following complex numbers. First one, 1 plus I root 3 whole square. See, and we know that multiplication inverse of a complex number z is z inverse, that is 1 by z. multiplication inverse of a complex number z is z inverse or 1 by z. Now first we will find the multiplication inverse of first one, that is given complex number z is equal to 1 plus I root 3 whole square. Okay. See here given complex number is not in the form of a plus ib. Okay. After finding a plus ib, then we will find the multiplication inverse. Okay. So first of all we have to make it in the form of a plus ib standard complex number. Then we will find the multiplication inverse. Okay. So first of all expand this one. Okay, a plus b whole square, it is in the form of a plus b whole square, that is a square plus b square plus 2ab. So 1 plus b square 3i square plus 2 root 3i. Okay, a square plus b square plus 2ab. That is equal to here 1 plus 3i square, the value of i square is minus 1. So minus 1 into 3, it will become minus 3 plus 2 root 3i. That is equal to minus 2 plus 2 root 3i. Okay, now it is in the form of a plus ib, right? Now let us find the multiplication inverse, that is z inverse or 1 by z is equal to 1 divided by minus 2 plus 2 root 3i. Now we have to make it in the form of a plus ib. Okay, by multiplying, by simplifying, that is by multiplying and dividing by conjugate of denominator. Multiplying and dividing by conjugate of denominator. Conjugate of denominator is minus 2 root 3i divided by minus 2 root 3i. Now simplify this one. That is 1 into this one, that is minus 2 root 3i itself divided by, now it is in the form a plus b into a minus b, that is a square minus b square, minus 2 into minus 2, 4, 2 root 3i into 2 root 3i, 2 into 2, 4, root 3 into root 3, 3, so 4 into 3, 12, so minus 12i square. Okay, that is minus 2 root 3i divided by 4. Here I square value is minus 1 into minus plus, so plus 12. That is equal to minus 2 root 3i divided by 16. That is equal to, see here 2 is common in numerator and denominator. So let us take it out and cancel. Okay. So 2 into minus 1 minus root 3i divided by 2 into 8. 16 is 2 into 8. That is equal to 2 cancelled. So minus 1 minus root 3i divided by 8. Okay. That is minus 1 by 8 minus root 3 by 8i. Now it is in the form of a plus ib, standard complex number, and it is the multiplication inverse of given complex number 1 plus I root 3 whole square. Let us do second one. Given complex number z is equal to root 5 plus 3n. See here given complex number is in the form of a plus ib, that is standard form, right? So directly we can find the multiplication inverse, that is multiplication inverse z inverse is equal to 1 by z, that is equal to 1 divided by root 5 plus 3n. Now we have to make it in the form of a plus ib by multiplying and dividing by conjugate of denominator, that is into root 5 minus 3i divided by root 5 minus 3i. That is equal to, now simplify 1 into root 5 minus 3i, that is root 5 minus 3i itself divided by, now denominator is in the form a plus b into a minus b, that is a square minus b square, root 5 into root 5, 5 minus 9i square. Okay, that is equal to root 5 minus 3i divided by, here 5, I square value is minus 1, so minus 1 into minus plus, so plus 9. That is root 5 minus 3i divided by 14, root 5 divided by 14 minus 3 by 14i. Okay, see now it is in the form of a plus ib, and root 5 by 14 minus 3 by 14i, or you can write I 3 by 14. It is the multiplication inverse of given complex number root 5 plus 3i. See the next question. If z1 is equal to 2 minus I and z2 is equal to minus 2 plus I, find imaginary part of 1 by z1 into z2 conjugate. So here we have to find the imaginary part, okay, imaginary part of 1 by z1 into z2 conjugate. So for that we have to find the 1 by z1 z2 conjugate. For that we have to find z1 into z2 conjugate. So before that we have to find z2 conjugate. Okay. So let us find z2 conjugate. z2 conjugate, that is here z2 is minus 2 plus I. So z2 conjugate is nothing but just changing the sign of imaginary part, right? So that is minus 2 minus I. Okay. Next let us find z1 into z2 conjugate. Okay. z1 into z2 conjugate. That is z1 is 2 minus I into z2 conjugate minus 2 minus I. Expand this one. Minus 2 into minus 2 minus 4. 2 into minus I minus 2i. I minus I into minus 2 plus 2i minus I into minus I plus I square, that is equal to minus 4. Here minus 2i plus 2i cancelled, and minus 4 minus 1, that is minus 5. Okay, see here we have got z1 conjugate, z1 into z2 conjugate is minus 5, and it's a real number, okay, and here imaginary part is 0. Okay, we can write a real number as, see, minus 5 plus 0i, right? So here imaginary part is 0. So here 1 by, we have to find the imaginary part of 1 by z1 into z2 conjugate, right? So 1 by z1 into z2 conjugate is nothing but 1 by 5. So 1 by minus 5. So here minus 1 by 5 is the value, that is 1 by z1 z2 conjugate. This can be written as minus 1 by 5 plus 0i. Okay. So here imaginary part is 0. So we can write imaginary part of 1 by z1 into z2 conjugate is nothing but 0. Okay. See here we have got, here no need to write, okay, because we have to find the imaginary part of 1 by z1 into z2 conjugate. So first of all let us find z1 into 1 by z1 into z2 conjugate. After finding z1 into z2 conjugate, then write 1 by z1 into z2 conjugate, that is nothing but minus 1 by 5, and write it in the form of a plus ib. Okay, it's a real number. Write it in the form of a plus ib, that is minus 1 by plus 0i. Okay, and here imaginary part is 0. Therefore imaginary part of 1 by z1 into z2 conjugate is 0. Let us go through next question. Find the least positive integral value of n for which given complex number 1 plus I divided by 1 minus I whole raised to n is real. Okay. See here we have to find the value of n, that is a least positive integer, such that this complex number should be a real number. That means, see, after simplifying and make it in the form of a plus ib, and there should be imaginary part 0. Okay, that means the imaginary part of this complex number should be 0. Okay, so what is the least positive integer value of n? So here So for that, first of all, let us substitute least positive integer value, that is n is equal to 1. Okay, let us substitute when n is equal to, whether n is equal to 1 if it is real or complex. Okay, that means after simplifying we should get a real number, no imaginary part, only real part. Okay, so let us substitute n is equal to 1 and let us check whether it is real or not. Okay, so substitute n is equal to 1. If n is equal to 1, 1 plus I divided by 1 minus I, right? Given complex number is 1 plus I divided by 1 minus I, and simplify and make it in the form of a plus ib, that is by multiplying and dividing by conjugate of denominator, that is 1 plus I divided by 1 minus I into 1 plus I divided, its conjugate, right? 1 plus I, that is here a plus b whole square, right? Okay, a square plus b square plus 2ab, that is 2i, divided by here a minus b into a plus b, a square minus b square, 1 minus I square, that is here 1 plus I square value is minus 1, so 1 minus 1 cancelled, so 2i divided by here 1 minus I square is minus 1, so minus into minus 1, that is plus 1, so 1 plus 1 2, so we have got I. Okay, when n is equal to 1, it is nothing but I, that is I is a complex number, not a real number, right? So here we have got I, so not n not equal to 1. Now let us check 2, n is equal to 2. What about 2? When n is equal to 2, 1 plus I divided by 1 minus I whole square. So first of all, let us expand this one. 1 plus I whole square divided by 1 minus I whole square, that is 1 plus 2i plus I square divided by 1 minus 2i plus I square, right? That is here 1 I square is minus 1, that is cancelled. So 2i divided by 1, here also I square minus 1, that is cancelled. So minus 2i, so here 2i cancelled, only minus 1 is remained. So here we have got minus 1, it's a real number, right? So when n is equal to 2, this complex number is minus 1, a real number, and here imaginary part is 0, that is real number. Okay, so what is the least value of n? That is n is equal to 2 is the least integral value for which this complex number is real. Find the real values of theta for which the complex number 1 plus I cos theta divided by 1 minus 2I cos theta is purely real. Okay, so here we have to find the value of theta when its imaginary part is 0. Okay, it's purely real means its imaginary part is 0. So first of all, make it in the form of a plus ib and that imaginary part equal to 0, so that we will get the value of theta. Okay, so here what is the value of theta? So first of all, let us take here z is equal to 1 plus I cos theta divided by 1 minus 2I cos theta. Okay, we have to make it in the form of a plus ib. So how? Multiply and divide by conjugate of denominator, that is equal to 1 plus I cos theta divided by 1 minus 2I cos theta into 1 plus 2I cos theta divided by 1 plus 2I cos theta. Okay, now simplify. Here 1 into 1, 1 plus 1 into 2I cos theta, 2I cos theta plus I cos theta into 1, I cos theta plus I cos theta into 2I cos theta, I into I square, that is 2I square cos square theta divided by here a minus b into a plus b, a square minus b square, that is 1 minus 2 into 2, 4, 4I square cos square theta. Okay, that is here 1 plus 2I cos theta, I cos theta, 3I cos theta, 3I cos theta. Here I square value is minus 1, so this plus will become minus. So minus 2 cos square theta divided by here I square is minus 1, so it will become plus. So 1 plus 4 cos square theta. Okay, see now here we have got real part, denominator as real part, okay, real number. That is, now split it, okay. So 1 minus 2 cos square theta plus 3i cos theta divided by 1 plus 4 cos square theta. That is, a is equal to, split it in the form a plus ib, okay. So 1 minus 2 cos square theta divided by 1 plus 4 cos square theta, it is real part, plus I into 3 cos theta divided by 1 plus 4 cos square theta. Okay, now it is in the form of a plus ib. And we have to find the value of theta when this complex number is purely real. That means it's when its imaginary part is 0. Okay. So what is the imaginary part of this complex number? That is 3 cos theta divided by 1 plus 4 cos square theta. 4 cos square theta, that is equal to 0. Okay, purely real means its imaginary part should be 0. So when its imaginary part is 0, what is the value of theta? Okay, so here when we take this denominator right side, so it will become 0. So 3 cos theta is equal to 0. That implies cos theta is equal to 0 by 3, that is 0. When cos theta 0, theta is pi by 2, right? That is 90 degree. Cos 90 degree is 0. That is theta is equal to pi by 2. Okay. So value of theta is pi by 2. Next question. Find the modulus of the following complex numbers. See here, if a complex number z is equal to a plus ib, okay, let z is equal to a plus ib be a complex number, then its modulus is nothing but modulus of z is equal to square root of a square plus b square. Okay, z is equal to a plus ib is a complex number, then modulus of z is equal to square root of a square plus b square. So here also we have to make a complex number in the standard form. Okay, after that we will find the modulus of a given complex number. Okay, so here first one, root 3 plus I. Okay, z is equal to root 3 plus I. So modulus of z, now it is in the form of standard form. Okay, so that is a plus ib. So here directly we can find the modulus of this complex number. Modulus z is equal to square root of a square plus b square, that is real part. So root 3 square plus imaginary part 1 square. Okay, that is equal to square root of root 3 square is 3 plus 1, root 4, that is 2. Okay, so here modulus of z is equal to 2. Next, second one. Second, 1 by 1 plus I. Okay, see here this given complex number is not in the standard form, that is a plus ib. So before, see, first of all we have to make it in the form of a plus ib, then we will find the modulus. Okay, that is 1 plus divided by 1 plus I into 1 minus I divided by 1 minus I, then simplify 1 minus I divided by 1 minus I square, that is 1 minus I divided by I square value is minus 1, so 1 plus 1, that is 1 minus I divided by 2, that is 1 by 2 minus 1 by 2 I. Now let us find the conjugate. Okay, that is z conjugate, modulus of z is equal to square root of a square plus b square, that is square of imaginary part, real part 1 by 2 square plus minus 1 by 2 square, that is equal to square root of 1 by 4 plus 1 by 4, that is square root of 2 by 4, that is root 2 divided by 2, that is 1 by root 2. Okay, so here modulus of 1 by 1 plus I is 1 by root 2. Next given complex number is z is equal to sine 120 degree minus I cos 120 degree. Okay, so here it is in the form of a plus ib. So directly we can find modulus z square root of a square, that is sine square 120 degree minus plus cos square 120 degree. That is equal to, see here we know that sin square a plus cos square a is, that is equal to 1, right? So square root of 1, that is 1. Next question, solve the quadratic equation x square plus x plus 1 is equal to 0. Given quadratic equation x square plus x plus 1 is equal to 0. So here we will find the solutions using the quadratic formula minus b plus or minus root of b square minus 4ac divided by 2a. So here what is the value of a? A is the coefficient of x square, that is 1. B is coefficient of x, that is 1, and c is the constant term, that is 1. So substitute the values. Minus b, so minus b is 1, minus 1 plus or minus root of b square 1 square minus 4 into 1 into 1 divided by 2 into 1. That is minus 1 plus or minus root of 1 minus 4 into 1 into 1, 4. So 1 minus 4 minus 3 divided by 2. And minus 1 plus or minus root 3 can be written as minus root 1 into root 3. Okay. Sorry, root minus 1 means root of minus 1 into 3, right? Divided by 2, that is minus 1 plus or minus root of minus 1 into root 3 divided by 2. That is here x is equal to, we can write minus 1 plus or minus root minus 1, that is I root 3 divided by 2. So that is solutions are minus 1 plus I root 3 divided by 2 and minus 1 minus I root 3 divided by 2. So these are the solutions of given quadratic equation. So these solutions are complex numbers. Okay, these complex numbers are the solutions of given quadratic equation. Minus 1 plus I root 3 by 2 and minus 1 minus I root 3 by 2.